Let's transform a recursive function definition, for example, the classic factorial function, which will produce stack overflow errors for large settings of the input, into a version which is completely iterative and won't produce stack overflow errors even for large settings of the input. This example is going to consist of several steps. The first step is going to be identifying the recursive call in your factorial implementation. And the first thing that we're going to do is we're going to expand it out for clarity to figure out the different kinds of things that are going on here. There's a lot of things going on in this first line. We're making a recursive call. We're doing something with the result of that recursive call, and then we're returning that result. Let's go over an approximation of how Python manages its own internal call stack during a series of recursive calls to factorial. Because once you understand this really well, you'll be able to guess how we can mimic it in an iterative sort of way. How do we compute factorial where n is equal to 3? Well, we check to see if we're in the base case. N is equal to 3, which is not 1. So we need to evaluate this expression right here, n times factorial of n minus 1, where n is 2. So we need to go off and compute factorial where n is equal to 2. And in a similar way, again, we're not in the base case, so we need to evaluate this expression here. It's 2 times factorial of 1 now. And we don't yet have enough information to be able to compute factorial of 1, so we have to go off and compute that. Luckily, this time we are in the base case, so we know that that's equal to 1. So now factorial where n is equal to 2 knows that the value of factorial of n is equal to 1, where it was held up before, it knows it's equal to 1. So now it can finish off this computation. It's equal to 2. And similarly, factorial where n is equal to 3 now knows the value of factorial where n is equal to 2. It's 2. So now I can just do 3 times 2, which is the factorial of 2, and come up with 6. So with that understanding as to how Python internally manages a stack to carry out recursive function calls, let's try and come up with an algorithm of our own to mimic that process. Since Python uses a stack, and we're trying to mimic it, let's use a stack ourselves. So let's come up with a protocol where elements on the stack include instructions and also data. So this first instruction says to call factorial with the value of n is equal to 3. And the way that we do that is we remove this instruction from the stack and then push further instructions on the stack so that if we carry those out, then we will actually carry out this instruction of calling factorial where n is equal to 3. So what we replace that call to factorial with n is equal to 3 with, based on the previous reasoning that we just did, is it consists of a call to factorial where n is equal to 2. Once we have finished that computation, we can resume the call to factorial where n is equal to 3 and finish off that computation because we'll know this value, factorial n is equal to 2. So similarly, to call factorial of n over 2, we replace it with a call to factorial where of n is equal to 1, followed by resuming the computation of factorial of n over 2. So now to call factorial of n over 1, we know that it evaluates to 1 based off of the last slide. So one way that we can encode that is we can set this variable that the caller, the factorial call before us, can now peek into and know the result of that computation. So now how do we resume the call to factorial of 2? Well, we pick up right here. And we know now that the value of fact is equal to 1 based on the setting of this global variable. So we can multiply that result by 2 and get 2 and then set this result variable. And finally, now we're resuming the call to factorial where n is equal to 3. We now know the result of the recursive call factorial of 2 by peeking into this result variable. It's 2. So we can take that result variable, which is called fact here, multiply it by 2, and then save it into this result variable and then return it. to come up with 6. So now that we've gone over the iterative stack-based implementation with pictures and abstractly, let's actually step through the algorithm and a concrete example where we're calling factorial of 3 again. So we've just begun. The first thing that we're going to do is just initialize our stack to an empty stack, an empty list. And the first thing that we're going to do is insert the instruction to call factorial with n is equal to 3 up here. And we're going to initialize this result variable, which is going to contain the result of our recursive function calls. We're going to save values into that. And we're going to keep going in this loop while there's still something in the stack. So let's pop the first thing off the stack. Again, it's a call to factorial of 3, where n is equal to 3. This is a call action. So what we're going to do is we're going to grab the value of n for that call, check and see if we're in the base case. We're not. So hence, we're in a recursive case. So what we're going to do is insert 2 elements here, a resume and a call set of instructions. So now we know that this is the top of the stack right here. We need to call factorial of n is equal to 2, and then resume the call to n is equal to 3 once this call finishes, and this call should be able to know what the value of factorial of 2 is. So we're going to pop off the next action. Again, it's call. So we do the same thing, grab n, check and see if in the base case we're not, and then push these 2 instructions on again. Now we're going to pop the top value off again. We're calling factorial with n is equal to 1. Check and see if we're in the base case. We are. So let's communicate the result back to the caller, which was factorial of 2, by setting the variable result is equal to 1. So now the next thing we pop off is a resume of factorial of n is equal to 2 here. So we're in this resume case. We grab n because that was the variable that was in scope at the time. We perform the post calculation of multiplying n with that result, and then we return the result to the caller by setting this variable here, result. So result is equal to 2. And now all we have to do is just resume the call to factorial where n was equal to 3, grab n, it was equal to 2, multiply n by the result of factorial of 2, which was 2, and we get 6, and then we set the value of a result to 6, and we check to see if there's anything in stack. It's empty, so we're done, and we just return the result, and we're done, and we get 6.